Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on solving quadratics by factorization. So we're starting to look at quadratic equations. So quadratic equations have an x squared term. They're equations like x squared minus 6x plus 9 is equal to 0. So that is a quadratic equation. Now, if you remember, we don't want to solve this like a linear equation. We don't want to move everything to one side, try and get x by itself. If you try to do that, you'll be there all day and you won't get anywhere. What we want to do instead is factorize the expression. We want to write it as something times something, usually those two somethings are in brackets, is equal to 0, so we can use the null factor law. So we need to be able to factorize in order to solve quadratics. So let's look at factorizing. It turns out that the factorization method is going to be slightly different depending on whether the quadratic is a binomial, which means it has 2 terms, or a trinomial, which it has 3 terms. So remember, a quadratic has an x squared term. It's an expression with an x squared term. So this is a quadratic trinomial because there are 1, 2, 3 terms, and it's quadratic because of that x squared term. So let's look at binomials. So there's 2 methods that we need to know. We need to know highest common factor, HCF, and difference of 2 squares, which I call dots. Sometimes you will need to use both, but these are the methods you use for binomials. So before we get to equations, let's just say we have an expression like this. So x squared plus 5x is a quadratic expression because of the x squared term. We want to write it as something times something. So we have 2 terms, 1 term, 2 terms. This is a binomial. Both of these terms have a common factor. So the common factor is x. It doesn't always mean to be a number. So what we do is we write the common factor out the front, and we divide each term by that highest common factor. So in the brackets, we go x squared divided by x, and then we go positive 5x divided by x, which just leaves positive 5. So factorizing is the opposite of expanding. If I were to expand this expression, I would get what I started with. So let's say I have something like x squared minus 9. So this is a quadratic binomial, but there are no common factors between the 2 terms x squared and negative 9. However, we can use the difference of 2 squares rule. So the difference of 2 squares is when you have a square minus another square, you square root the first term, you square root the second term, 1 bracket gets a minus, 1 gets a plus. So for x squared minus 9, we just get 2 brackets, square root x, square root 9, and then 1 gets a plus, 1 gets a minus. So if you were to expand this using FOIL, binomial expansion, you would get this. So always see first if you can use highest common factor method. Sometimes you'll use both. Let's say, for example, we had something like 2x squared minus 98. So 2 is not a perfect square, nor is 98. So we can't really use the difference of 2 squares first, but they both have a common factor of 2. So I can take out my common factor of 2, and I'm left with x squared minus 49. Because 2x squared divided by 2 is x squared, minus 98 divided by 2 is minus 49. So now, what's in the brackets can be factorized further. That is the difference of 2 squares, because x squared is a perfect square, and so too is 49. So let's just factorize what's in the bracket. So we still have the 2 out the front. So we have square root of x squared goes in one bracket, and then we put it in the second bracket. Square root of 49, first bracket and the second bracket. One of them gets a minus, and one of them gets a plus, and then we are done. Once again, if you were to expand your final answer, you'd get what you started with. Now turn our attention to trinomials, but in this video we're just looking at monic trinomials, which means the coefficient of x squared is 1. We'll look in later videos how to do non-monics. So let's say we want to factorize the expression that's up there, x squared minus 6x plus 9. So this is monic because the number in front of x squared is 1. It is a quadratic because there's an x squared term, and it's a trinomial because there are 3 terms. So what we want to do is we want to write it as something times something, so that when we expand this using FOIL, we get what we started with. So the way we do monic trinomials, you find 2 numbers that multiply to the constant term and add to the coefficient of x. So we want to find 2 numbers that multiply to 9 and add to negative 6. In this case, those numbers are the same, minus 3 and minus 3. Minus 3 times minus 3 is positive 9, minus 3 plus minus 3 is negative 6. So you put an x in each bracket with those numbers. So that is the answer. We're done. So let's look at another example. Let's look at this example here, x squared plus 12x plus 32. I want to find 2 numbers that multiply to 32 and add to 12. So my answer is going to look like this with brackets. I put an x in each bracket. So the 2 numbers I'm looking for are positive 8 and positive 4. 8 plus 4 is 12. 8 times 4 is 32. Let's do one more example. X squared minus 5x minus 24. Once again, it's a monic quadratic trinomial. I know that it's going to look something like this. I'm going to have 2 brackets with an x in. So I need to find 2 numbers that multiply not to 24, but to negative 24 and add to negative 5. So because I'm finding 2 numbers that multiply to a negative, one of them must be positive and one negative. So go through factors of 24. 24 and 1 won't work, 12 and 2 won't work, but 8 and 3, I can make that work if I make it negative 8 and positive 3. Negative 8 plus 3 is negative 5. Negative 8 times 3 is negative 24. So let's now use this factorization to solve some quadratic equations. So let's say I have this quadratic equation here, 2x squared plus 14x equals 0. The goal is to factorize the quadratic expression and use the null factor law. So we have a quadratic binomial. There are 2 terms. So I'm going to use highest common factor. So the highest common factor of both terms is 2x. So 2x squared divided by 2x gives x. 14x divided by 2x gives positive 7. So the reason that we're doing this is because when we factorize, we have something times something. And if we have something times something equals 0, either the first thing is equal to 0, which would mean x is 0, or the second thing being multiplied is 0, and that would mean x equals minus 7. So they are the 2 solutions. If you substituted x equals 0, x equals minus 7 into this equation, you get a true statement. So quadratics can have 0, 1, or 2 solutions. We're really looking today at just the case where there's 1 or 2 solutions. So let's look at another example. So x squared minus 16 equals 0. Once again, I'm going to factorize this. So this is difference of 2 squares. So I square root the first, square root the second. One of them gets a plus and one of them gets a minus. So I have something times something is equal to 0. So the null factor law says either the first something is equal to 0, which means x is minus 4, or the second something is equal to 0, in which case x is positive 4. So positive 4 and negative 4 are the 2 solutions here. Let's look at another example. So now I've got another quadratic equation. This time it's a quadratic trinomial. X squared minus 10x plus 25 equals 0. So I'm going to factorize this expression and use the null factor law. Once again, I don't want to try and get x by itself. I don't want to subtract 25 from both sides. It just will not work. So I'm going to factorize this expression. Because this is a trinomial, I set up my brackets. Each has an x, and I find 2 numbers that multiply to positive 25 and add to negative 10. They're both minus 5. Minus 5 times minus 5 is positive 25. Minus 5 plus minus 5 is negative 10. So, null factor law. Either the first bracket equals 0, which means x equals 5, or the second bracket equals 0, but the second bracket's the same. So this one only has one solution, x equals 5. So let's look at this equation here. Now you might be thinking, oh, this is non-monic, what do I do? But we can make this into a monic easily. We can use highest common factor. So always check first if you can use highest common factor. So I'm taking out a highest common factor of 2 and dividing each term by 2. So negative 8x divided by 2, negative 42 divided by 2, and I get this. So if I have 2 times something equals 0, that's something equals 0. I can divide each side by 2 is what I'm saying. And now I'm going to factorize this just like normal. 2 numbers that multiply to negative 21 and add to negative 4. Of course, negative 7 and positive 3. So once again, the null factor law tells us either the first thing is equal to 0, which would mean x is equal to 7, or the second thing is equal to 0, in which case x is negative 3. So you can see that all the ones where the solutions are written in blue, they had 2 solutions. The one written in yellow is 1 solution, and that's what we're looking at today. You'll always have 1 or 2 solutions where you can factorize. All right, sorry for the long video. Thanks for watching. This has been the luckiest maths teacher in the world. Have a great day.